Hi, we're continuing with example 2 of applications of exponential functions. This is example 2, and we're looking at the half-life of a radioactive substance. So when something has a half-life, that means that there is decay, exponential decay. That means something is going down in number. The number is decreasing. Here we have it's saying that the radioactive substance has a half-life of 4 days. So that means every 4 days, you're going to end up with half the amount that you started with. So here, this equation's going to be P, that's the proportion that's left, equals, and then 1/2. The reason it's 1/2, the base is a half because we've got a half-life. So that's the base of our function. And then our exponent is t over 4. Now it's t over 4 because every 4 days, half of the substance is left and half is decayed, so half is gone. So we divide the t by 4. We divide the exponent by 4. And you could double check that if you note that when t is equal to 4, the exponent is going to equal 1. So you have t over 4, or you have 4 over 4, which is equal to 1. And if you have the half-life, so you end up with half to the power of 1 after 4 days. All right, now here in part B, it says use your function to determine the time that must pass until there is 25% of the substance remaining. So just a note, 25% is equal to 0.25, and that is a quarter. So you're going to use one of these two numbers in your equation. We're not going to use the percentages. So here, this is all P, what we're talking about, the proportion. So we have 1 over 4, and that's equal to 1/2. So we get this from right here, and then to the power of t over 4. Now we can change this so that it's written in a base of 2. So that's going to be 1/2 squared, and that's equal to 1/2, and this is to the power of t over 4. Now note they are of the same base, so we can equate the exponents. And I will do that just up here. So we end up with 2 equals t over 4. So that's this part right there. And then I can solve for t. So just multiply both sides by 4, and you end up with 8 equals t. And that means that there is 8 days where a quarter of the substance will be left. All right, so this is our answer. Okay, now in this question here, in example 3, we are looking at the number of bacteria in a sample, and it doubles every 10 hours. So now our base is going to be 2 because we are doubling. And our doubling time is 10 hours. So then we are dividing our t by 10. So at 10 days, it will double once. So then we have 10 over 10. So we divide our t by 10. Okay. Now, you could also write this equation all in terms of base 2. If you note that 64 is 2 to the power of 6, and you've got 2 to the power of t over 10, you can write it all as 2 to the power of 6 plus t over 10. Okay, so we're going to use this function to determine the number of colonies present after 24 hours. So our t is 24 hours, and we're simply going to substitute that into here. Then we get n is equal to 2 to the power of 6 plus 24 over 10. And we can simplify that so that we end up getting 2 to the power of 84 over 10. Now, let's make that into a decimal, and then we're going to estimate what our answer is going to be. So n is equal to 2 to the power of 8.4. Now that's a simple calculation you could do in your head. To estimate, you can figure out what 2 to the power of 8 is and 2 to the power of 9 is. And those were a couple of the common ones that we told you at the beginning would be good for you to be familiar with in case you are not allowed to do this with your calculator. Now, 2 to the power of 8 is 256. 2 to the power of 9 is 512. And the answer that we're looking for, well, we see here we've got 8.4. So it's going to be closer to the 2.8 than it is to the 512. And you see that there's a pretty big, it's going to be top heavy if we go anywhere close here. So let's kind of estimate, stick closer to our 256 number. So let's estimate it's somewhere around 350. Okay. If we are using our calculator, then we can just type that in and we get the answer. The actual answer is somewhere around 337.79, and it continues. Okay. So this would be an okay estimate. All right. Now, let's determine the time that must pass until there are 1,024 colonies present. Okay, so we're going to use n equals 2 to the power of 6 plus t over 10. And this is our n. So we're going to set up our equation and then solve for the time. Now, 1024, that's base 2. That's 2 to the power of 10. And solving my exponents, because I've got the same base, I have I've got here, I'll do that up here. I've got 10 equals 6 plus t over 10 minus 6 on both sides. I end up with 4 equals t over 10, and then multiply 10 by both sides. I end up getting t equals 40 hours. So after 40 hours, we are going to be left with, or we are going to have 1,024 colonies, because it doubles every 10 hours. So that is 4 doubling periods. Okay. So we can just write that, 4 doubling periods. All right, so I'm going to stop at this one and I'm going to do the next video, and we're going to look at something very exciting, which is money and compound interest. Okay, see you soon.